Hello friends, today we are going to solve one problem from previous year question paper. So let's solve. Data given here: piston diameter 200 mm. In terms of meter, it can be written as a 0.20 meter. What is asked to calculate the force exerted by the atmosphere. So first we should calculate the area of the piston. Area of the piston equals to pi by 4 into d square equals to pi by 4. We have d 0.20 meter, so area becomes 0.0314 meters square. Again we have the mass of the piston and the weight together is 100 kg, so we can write as a mass of the piston plus weight on it equals to 100 kg. Again the force exerted by the piston and the weight on the gas. Force exerted by the piston plus weight. We can write it as a F1 equals to m into g. We have m, that is 100 kg, and acceleration that is given in a data g equal to 9.81. So force becomes 981 Newton. Then we have atmospheric pressure. Atmospheric pressure, which is given in a data, equals to 1.01325 bar. In terms of Newton per meter square, it can be written as a 1.01325 into 10 raised to 5 Newton per meter square. So again force exerted by the atmosphere. We can write it as a F2. It will become pressure into area of the piston. So we have pressure 1.01325 into 10 raised to 5, and we have area of the piston 0.0314. So the F2 becomes 3181 Newton. Total force, again the total force acting on the gas equals to F1 plus F2. We have F1 is equal to 981 and F2 equal to 3181. So total force acting on the gas is, by adding these two, 4162 Newton or 4.16 kilonewton. Then our second question is the pressure of the gas. So pressure of the gas, for pressure we have formula, that is force per unit area. We have total force, that is 4162 Newton, and we have area of the piston 0.0314. So the pressure of the gas is 132547.8 Newton per meter square or 1.325 bar. Again our third option is the work done by the gas. If the gas is allowed to expand, pushing up the piston and the weight by 500 mm. So here displacement is given, that is 500 mm. So can write as a displacement of the piston due to expansion equals to 500 mm. In terms of meter, it will become 0.50 meter. So the work done by the gas, for work done we have a formula, that is force into displacement of the piston. So total force acting on the gas is 4162 Newton and displacement we have 0.50 meter. So the answer is 2081 Newton meter or 2081 joule. Hope you will understand this problem.